Now, one of the major obstacles that you might find while trying to gain access to a network is if the network does not broadcast its name. So, if the network is hidden, that you want to be able to connect to that network, even it does not use any network, you cannot connect because the network is hidden. So, if it uses a password, then you want to be able to use the attack that we are going to talk about in the future lectures. So, you literally want to be able to do anything and until you know the name of the network. So, just for an example, like if you have a network and you set it as a hidden and you check that box SSD mask. So, this could be called something else for you again. So if you set your that network as a name, then it doesn't actually broadcast the name in the air. So I also said the network does not use any security, so people can connect as long as the network has their name. So if you go and check out my Windows, as you can see, all of them uses a password protector. So I can really test that without password on. So as you can see, all of those are in password protected. So if it's using a password for the network, then we want to be able to launch this attack. Then if we don't know the name, if you cannot target and target is hidden, the first step is always try to determine the name of the network regardless of whether it uses encryption. So if it uses a password or if it does not use a password. So in this lecture I am going to cover how to determine the name of the hidden network and how to connect to the network. Now I am going to test that. I also previously described this. So what you have to do now is you have to use our command use dump engine. So put your name in the wireless scan, then just hit enter, then this page will come up. Then you can see the hidden network that are around us, so which is this one. As you can see, this is the open network. So you can see that we can actually get the all the information of the network, and we can get the MAC address. So we can see its distances, we can see beacons, we can see distance, beacons, data, and if there is a lot of data, then we can see the encryption. As you can see, most of them are WPA2 and couple of them are open. So you will see it uses WPA or whatever. So the only thing that is name of the internet. So you can see here this one. So basically when a network is configured to be hidden, it only hiddens the network name, but it is still broadcast. So it broadcast is existent, and I am telling all the differences around it, that I exist, my MAC address, and this is the ESID, and it, as you can see, it also has MAC address. So it given all the information except the name. And basically what I am saying, and if you know that, if you see your network name, you can connect. So we are going to do is, now we are going to run this dump engine, and because that's our target. So basically we already done this previously, how we can do this. Please go check that out. I already described all of this detail. So what you're going to do is, you're going to run the dump engine, and you're going to specify a BSS ID of the targeted network, which is like a MAC address. Then you're going to specify a channel channel than the target network, then give you the wireless card in monitor mode, which is 10. So as you can see, there are a lot of aerodynamic. So we are giving it a MAC address. So it is in monitor mode, and as you can see, this is running on against a specific network, this network. So in many cases, if the target network is big active, you will see that you will be able to get the name of it simply by running a Aerodom NG against it. So in our case, we can see that the network is not active, but it is open, but it is not active. So it will not be able to determine its name. But what we can do also is to see, we can see there is a client connected to the network right here, because as we said the second lecture that Aerodom and NG shows us the connection or connected devices. So we can see that there is a device connected to this network and the device has MAC address. So what we are going to do is, now we are going to use authentication attack, and what we did like before, we are going to disconnect this device and from this network, but we are going to actually disconnect it very short period of time, then it automatically reconnects on the target network. So what it does is, it's going to send the network name in the air, since we have like Aerodom NG engine running, and it will be able to capture the name, and it will show us here that it will show us here the name, and it will tell us that we note the name as a network. So again, the attack is very simple. All you're gonna do is we are gonna type this command or this line, just airplay ng, just type this, and this would be your connected machine and the MAC address. So we will be able to capture the name and we will be know the network name. So just type this and press enter, and it will a chance. So what you're gonna do is, then MAC address, give you the MAC address, then do -C, and then give you the MAC address of the client that I want to disconnect, and finally name of the wireless card that you want, and after that this one is the one which is on the monitor mode, and specify the authentication packet, which is a really big number in here. So we're gonna keep the target computer disconnected for as long as possible. So in this discussion, we actually want them to disconnect for a split second, so we use this as 4 packets. So usually 2 is sufficient, but I'm just going to use 4 just to make sure that target device is still get disconnected. So it's a little, because we are using a very small number, and it will be disconnect for a very short period of time, and the target person who is using the network will not even feel that. So the same command that we did before, nothing different, like airplay. We are doing a deal authentication attack, and we are using a very small number of packet in here, because we don't want to target the person to feel that they got disconnected, because if you disconnect it for a couple of minutes, then they will notice that it's disconnected. So it's better to use a small. Then we give the MAC address of the target network, then after this option, after a option, then the MAC address of the client, then I have to disconnect. So after that, just you press enter, and also you have to type your network monitor machine. So just type enter, then and it will show you the network. As you can see, it is the test this is the network name. As you can see, previously it was 0, means it doesn't have any network name to show. So now as you can see, it shows the network name. So arrow dump ng is still not that the. So now if the network is open, like in our case, we can actually go ahead and connect to that network. Or if the network is using an encryption like WPA or WPA2, then we actually know the name of the network now, and you will be able to launch the attack. And you are going to learn in the next lecture that against that network and determines its key. So the attack was very simple. All you had to do is run a dump ng against our dump ng command or dump ng function attack against our specific targeted network, and then the authenticated one of the client that very a very short period of time, like in 4 packets, and then they will automatically get connected to the network. And what they do is they will know its network name by using this method. So now let me show you how to connect to a hidden network, because the process is a bit different than connecting to a normal network. The main thing is that since I was using a dump ng and I put my wireless CAN 8 monitor mode, so if I go and try to connect, nothing will gonna be happen, because and I am in monitor mode. So I won't even be able to discover the hidden network, because as we said before, you cannot connect to the network when you are in monitor mode. Monitor mode is only used if we want to capture packets that are not sent to us. So it cannot associate it with the specific network. So to connect a network, we need to be in the manage mode, which is the default mode. So you can just put your card back in the manage mode, or you can just restart your Linux and it will all be in a default mode. So what you have to do now is you have to as you can see in here, you have to connect to a hidden network. So what you're gonna do, go to the setting and click on a application. Firstly you have to go to a Linux machine. So when you go to your Linux machine, it will show up here all the system setting. So after giving all the system setting, and you will go to the application and Wi-Fi setting, and as you can see in Wi-Fi setting, in the lower end in here, as you can see, connect to a hidden network. You can connect to this hidden network which is name is test_ap. You can connect this into your hidden network. So just press the connect to hidden network, and then this page will show up. So it's gonna ask me to put the security, put the connection and Wi-Fi security in this here. So in this connection we will set it as new, and in this network name, as we set it as test_ap, because our hidden network name is test_ap. So we just put it here, and you can select your Wi-Fi setting like as web or WP or WPA2, then you can specify it in here. But as we are in a hidden network and our security is none, so we will just select this as none. So if you just press connect in here, then I managed to connect to this network. As you can see, this is an active on test underscore AP. So if we go to the setting now, this network actually does not have internet connection, because that's why there is a very low data going in when this was in here. As you can see, very low data. So if you go to this connection setting, but as you can see, I am connected to this network and I have a good signal strength. I have got like my IP address and the default gateway, and our link speed, as you can see, pretty decent. Our IP4 address, IP6 address, our hardware access, and our main root address. So I can do anything I want now on the network because I am fully connected to it. So when it comes to connecting to a network, you need to just keep in mind that your wireless card has to be in a default mode, means manage mode, not in monitor mode. That was previously in here. So as we were working in here, it was in monitor mode. That's because of that we can monitor this, because if it was in default mode or manage mode, you cannot do this. So that's why it has to be in monitor mode, and in this it has to be in default or manage mode. Then you can come back and connect to the hidden network. Put the network name, then you will be able to connect. As I said, hidden network can make a major obstacle, because if the network is open, you won't be able to connect. So if the network is using a password, then you can even start doing the attacks that we are going to talk about until now. So the name of the network is the must. You must have to know this. So the first step is always, as I previously told you many times, you need to know the name of the attack, name of the network. Hello everyone. So in this lecture, I will be talking about the packet sniffing using AeroDumpNG. So previously we talked about how we can have our setup like a Wi-Fi card and monitor mode. Now we will sniff all the packets that are within our Wi-Fi range, even though they are not directed to our device, and even without connecting to any network, even without knowing the password or the username of the network. So what tool we are going to use? So we are going to use a tool called AeroDumpNG, and it is a part of the aircraft unit. So it's a packet sniffer which allows us to capture all the packets around us, so we can run it against all the network that are around us. So we'll collect any packets that are within our Wi-Fi range, or we can just run it against a certain IP or access point. Then we will be able to collect the packets that are coming from a certain Wi-Fi network. So we'll describe how this works. First, what you have to do is you need your Wi-Fi card in monitor mode. So because I already have my Wi-Fi card on my monitor mode, then you will just run a simple command, which is this one, AeroDumpNG and mon-o. So it is just a simple code, and after typing this code, the name of the Wi-Fi card that has been enabled on it will be monitored. As you can see, it's starting to list all the network that are around us. So another use of AeroDumpNG is to identify all the network around us and to identify all the connected devices to these networks. And I'm just gonna it will continue to run, so you have to stop it. So how can you stop? You just press Ctrl+C on your Linux machine and it will stop this from running. Now I will take a quick look. Now all the facts that we are sniffed now, we didn't save them anywhere, so there was really no point to analyze in the packet because we are just run it against all the access point around us to see what networks are that are around and what and how they are gathering information about these networks. So you can see that there is quite a good bit of information around me, and the BSS ID is the MAC address for this access point. So these are the MAC address of this point ESS ID. Column is the power of the column is the power in the power. So it's how far the access point from our Wi-Fi card. So you can see the test IP. This is, so you can see BSS ID, you can see power, you can see beacon data and cheaper authorization and ESS ID, all of this in here. So there is a test router that we are running, because as you can see this is the test router. So it's very close to me and it's like -34, as you can see. So you can see, you can go down on the network that are farther and farther away from me. So the closest the network, the easiest for you to set the sniff packet, and because obviously you are closer and the packets are that can be collected easier. Also all the attacks that you are gonna explain, we are gonna explain in the future. The closer the network to you, the more effective the network and the attack will be, and it will be also quicker. So you will gain your access and achieve your goal beacon. So beacon is the signal. So because the network that I am here, I have my BSS ID to be like this, and I am running on this information. So this is the number of beacons, and that each exit point is sending the data in the number of useful point that we have sniffed, and we will talk about this later when we start talking about web decrypting and web encryption. So we will just leave this for now, and is the number of packet that we have collected in the past 10 seconds. So as you can see, we have 0 in here. So 0 data packet in past 10 second channel is the number of channel that the access point is broadcasting on. So each access point broadcast on a certain channel, and this is used to, because there is no interface between access point and there are also besides each other. So say for example, I have an access point, and so here 20 beacon like 5 meters away from me. So there is another access point. So if both of them are running on the same channel, and there will be interface between these two access point, and the signal between them will be shorter. So the range of this access point will be shorter. So with different channels, so that there is no interface between the packets that are sent in the air. So MB, this is the maximum speed support by the access point. So it can go up like 54E is the encryption that used and the access point. So we see the encryption here as ENC. So here is WEP, WPA2, as you can see WEP, WPA2, and you can see here is OWASP again. So we have WPA here and WAB also in here. So it's an open network, and you will see an open when encryption cipher is decided for that. So choose to decrypt the packet. So for WIP it's web, and for WPA2 it can be CCMP. As you can see, for web it's web, and for WPA2 it will be CCMP, and it could be also TKIP as well. As you can see, from WPA it can be also TKIP. So we'll talk about this later when we get into the WPA cracking, then of the type of authentication that requires the access point. So we have pretty much all PSK shared key. So we have MGT. As you can see, for this we have MGT, and we will talk about this later as well when we go to WPA cracking. So now we'll talk about how to target those packet sniffing using AeroDump NG. So previously we saw how to use AeroDump NG to see all the network that are within our Wi-Fi range and collect the information about those network, such as BSS ID and the channel, and the distance between us and the access point, the encryption that I use it in, and so on. And now what we'll do is we will see eventually, and we will see a certain network that we want to target, or number of network that we want to target. So once we have our target selected, it's more useful to run AeroDump NG on that network. So instead of running it with all the network around us, in this lecture we will talk about how to use that to sniff a specific network. So what you have to do now is you have to type this code in the terminal, so that as you can see, I am going to target this machine. So that's my home network, and that's and I am going to start sniffing on that network instead of sniffing all the network that are around me. So we are going to use the same program to use this. So first what you have to do is you have to use code AeroDump NG, and then we are going to specify the channel. So specify the BSS ID, as you can see, and the MAC address, and the target network, and the write test. So write option, this tells arrow to dump engine in the log, and then all the packets will be captured in this file and name. So I am going to call it test UTP. This is the file name, and then we put the name of our Wi-Fi card, which is Mon0. So same as the program that we used before. So we put the channel of the target that access the point, and BSS ID that will put the MAC address of the target access point. So we put the file name that we want all those packets to get started, and we want to have 10, and the name of Wi-Fi card and monitor mode. So if you just type this and press enter, you will see something like this. As you can see, the only network that shows up in here is this one. So we don't have any other network with us, so which can have a look in this section. So in the previous lecture we had too many networks that we had connected around me. Now we had only one section in AeroDump engine. The section was missing here in the second section in here, because previously we only saw this part. In here it is only one, but previously we saw many of them, as you can see, many of them. So the first section, as we saw, that contain all the access point that are within our Wi-Fi range, and this section in here, the second section, contains all the client that are associated with the access point in here. So this is not the network, this is a client, so it's connected to the network. We know that because we have the BSS ID. So that's the MAC address of the network, that is client to connected. So to MAC address, connected to the MAC address here, which is the same as the MAC address. So that means that client is connected to the network. Now this is the station, is the MAC address of the client. So this is the MAC address of the device that is connected to the network power. As you can see, this is connected to the network power, and the distance between us and the device rate is maximum speed. And the device is running on. So last, the number of packets that we lost. We lost including capture from the target device. So the frames of the numbers or numbers of useful packets, so we collected from that device, that will talk into the this network. So we'll talk more about the frames and data in future. So as I said, when I start talking about web cracking, so we just have to show you now the two main parts. So the first mini part of this access point that are within our Wi-Fi range. The second part of this AeroDump. Then second, which is the client that are associated. So with this access point, we have the MAC address. That are of the access point, and the market address that are actual client in here. So if you just, this will continue running. So this will continue running. So what you have to do, you have to cancel this by Control C. So when you cancel this, this will save all of this, and this will save the log into a file named as test UPC. So what you can do is, you can list all of those test UPC. As you can see, this is the file that saved, that AeroDump created. So what you can see, that there are lots of file, 1 2 3 4 5 1 2 3 4 file. So there is a file that has different extension, like a couple of them has cap, CSV, and one of them has Kismet.dal net XML. So if you go to your home directory where you save this, test file, you will see all of those files in your directory. So what you can do now is, you can after that you can see where those router are. So we can sniff those packets, and we can use a program such as you all remember Wireshark. We can use Wireshark to analyze those pockets and see the information that we gather in here. The problem is that the net specific network is that WPA encryption. So all the packets that are encrypted are in here, and we want to be able to decrypt them unless we have the key. So we'll talk about in the future how we collect the key in the future lectures. So if you want to test those files on Wireshark, you can do that, but they will not show you many information of those files because they are WPA connected. So that's how you use a specific or targeted packet to sniff using arrowdump command, arrowdump ng. So in this lecture we are going to be talking about the pre-connection attacks. So previously, as you know, you already know, I think, how to install Kali Linux and all of this, because we are gonna use Kali Linux. And if you don't know how to install Kali Linux, just a simple Google search will get you all the results. It's pretty easy. So just install Kali Linux on your virtual machine, or you can use any machine, that doesn't matter. So in this lecture we are going to dive into straight hacking. So it's going to be a basic section or basic lecture. So we are going to visit some basics that you already know, and I'm going to show you how to extend it and build up the information that you know. For example, I'm going to show you how to change your MAC address manually, so you will be able to change the MAC or any device that support that, and without the need of any optional tools. You will use it in a simple couple of commands and it will be changed. And I will show you how to extend all the pre-connection attacks so that you can target networks and clients that use like 5 gigahertz etc. And see, finally you are going to extend the authentication attacks, and so you will be able to run it against multiple device and multiple network all at the same time. Not only that, but you will be able to target all devices and all networks around you and manage all of this connection and control them. So throughout this lecture I am going to be using Kali Linux machine as my hacker machine, and it's going to be installed as my virtual machine. As you can see, you can install it as a main machine, that doesn't really matter. And whatever or whenever I run the wireless attack, I am going to be using a wireless adapter, because my PC is connected on a direct Wi-Fi network, as you can see in here. So I am going to use a wireless network. So if you have a LAN network, then as you can see, you can find those LAN network. You will be seeing those LAN network under this one here. As you can see, Ethernet, this one is mine. So now I previously talked or described or demonstrate how to use Kali Linux and connect a wireless adapter, and in general it's pretty easy, and I think you already know how to do that. So let's go to now this virtual machine, and now we'll bypass the blacklist or whitelist and how to hide your identity by changing your MAC address, and we'll see how to do that using a tool. So in this video I want to show you this way without any tool that can change your MAC address within this command. So this method we are going to be talking about doesn't need any program to be installed on the system. You can use it in a native ifconfig in your Linux machine. As you can see, I have already done this. So first you just type ifconfig, it will give you all the network, connected network, and this is my connected network. As you can see in my MAC address. As you can see, my previously my MAC address was this. So what you have to do now is you have to configure this MAC address, and you want to change this MAC address, and then what you have to do is you have to put this interface down. So just typing this down, it will disconnect your disable your network from this machine. So after that you just type this ITH0, this one is my this connection network, and just type HW ether, and this is for the right. So we have given it the interface that we want to modify its properties, and we are going to tell that we want to change this hardware, and we want to change the value of the ether property. So you can see that MAC address is shown up in here as ether, so we will change this ether. So I want to change this ether, and we want to set the MAC address, right? So you can just type any MAC address that you want. So I will type a random one. So after just typing this, just and press enter, as you can see it will not show any problem. Then after that, what you have to do now, as your internet is down, you cannot check your MAC address. So what you have to do now is you have to up your internet or up your network connection in this machine. So just type up, as you can see, if config UTH0 up, and it will be all up and connected. So after that, just type ifconfig to check the IP address again. As you can see, my IP or my MAC address or ether address is already been changed to this one, which previously was this one. So as you can see, it's pretty easy, and you can do it manually with just a couple of command line. And you can use it on a different Linux system, or so you can also use this on a Mac changer and optional software, which is you have to use a little bit more steps, but I think this is pretty easy to change within the command line. As you can see, it's just only one line that you have to type to change this MAC address. So without installing any optional software, you can just do it this in natively. And so that's all about how you can change your MAC address in here on command line. So for everything we have done, we didn't need to connect to any network to do it. So the good thing about connecting to a network is that you will be able to launch more powerful attacks and get more accurate info when you connect to it. Now if the network doesn't use encryption, so if it's an open wireless network, you can go ahead and connect to it, and then you can escape, so you can sleep on encrypted data. So if the network is a wired network, then you can connect to it using your wire, or you can try after you connect to it with the wire. Maybe you need to change your MAC address to something else so that you can connect to the main problem. But the problem is that if the network uses encryption such as OFWPA or WPA2, we have seen if we try to sniff the data and the data will be encrypted, and if we want to decrypt it, then we need to know the key, and if we know the key, then we can just connect the data and that will be encrypted. Anyway, that's the main purpose of this lecture, is that if you target your network that uses some sort of encryption and you cannot really do anything more now unless you decrypt or find the key, so that you can decrypt the data and connect to the network. So we're going to talk about how to decrypt WPA or WPA encryption. So the first encryption that we are going to talk about is WEP or web cracking or web breaking. It is going to be a web encryption because it's the oldest one, is the easiest one to break, but we still don't know or still need to learn how to break it, because you will see networks that still use web application with encryption uses an algorithm called RC4. Each packet is encrypted at the access point and then it's sent to the air. So once the client receives it, since the client has the key, it will be able to decrypt the packet and read the information that are all inside. So very simple. Apply the IP encrypt on the packets and send it to the client to receive it. Then the client has the key, so the client then decrypts it. Same way, when the client sends the packet, it encrypts it and decrypt it and send it to the air. The cog and the access point then receives it. The access point has the key, so it will decrypt the package. So each packet I sent into the air has a unique key stream and ensures that the key stream is unique using a 24-bit initializing vector. So the initializing vector is a random number. It's sent into the packet and it's sent into a plain text. So this part is not encrypted. So if you read a packet, and you'll be able to read it a plain text. But the problem with this is the IP or the initialization is very short. It's just 24-bit and it's not that long. So in a busy network, there will be a very large number of packets that are sent into the air. This means the number of possibilities of random IPs will be exhausted, and we will have two packets that have the same initializing vector. So the initializing vector is 24-bit random key. It's sent into the air in each packet, and it sends into a plain text as a plain text in a busy network. So we are going to have a very large number of packets. This means that the possibilities of unique IPs will be exhausted, and then we will be able to sniffing this all those packets, and we will be able to collect those packets who have the same initializing vector. So once we have two packets and they have the same initializing vector, and then it will be use a statistical attack to determine the key stream, and after that it will be determine the web key. Okay, so from the above we know that the more IPs are initialization vector that we collect, the more likely that we will be successfully to crack the web key. So our main goal when we try to crack web is to collect as much as IPs as we can, because once we have a large number of IPs, then we are going to have like two packets, then we will use the same IPs, then it sends the air to crack the packet, and which is more likely able to determine the key stream and the web key for the targeted network.